Hi guys, welcome back to the channel. So today we are going to be solving today's lead code question, which is middle of the linked list. So we are given a head of the linked list, which is like 1, and then we need to return the middle node of the linked list. So for this particular case, we have 1, 2, 3, and then 4, and then 5. For this particular case, we need to return this 3. Why? Because this will be the middle of the linked list, and then we'll consider for this particular case, as it contains like two middle elements, which is 3 and 4, we need to return the node which is like the second middle element. So we are going to return this particular case. For this, we are also given constraints that the number of nodes in the list are in the range of 1 to 100, and then the values is also 1 to 100. So we can solve differently for this. So let's come to brute force approach. Suppose let's say we want to find the middle of the linked list. So to find the middle of the linked list, we need to traverse not total length. We'll traverse only till the half of the length. That means suppose let's say this length is 5. So we need to go through till a third element, which is going to be the length of the linked list plus 1 by 2. By 2 we'll do, and then we'll traverse till that particular point, and then we'll return the node which is present, which is here. And then again we'll go through all the elements which are present in the linked list, and then we'll find the length of the linked list. After finding the length of the linked list, we'll try to for this particular case it is 6. So we need to travel till 4. Why? Because it contains two middle elements. So we are going to say n plus 1 by 2, and then for this particular case we need to add one more. Why? Because it contains two middle elements, we are going to take the later one. And then as we can say that the time complexity will be big O of n, and then the space complexity uh, will not be big O of n, it will be big O of 1. So but we are traversing the linked list twice. First for calculating the length of the linked list, and then the second we are doing it for again to find the middle element of the linked list using the length. So for this particular case, we need to optimize this so that we can solve the solution via only one traversal. That means we need to travel the linked list only once. So let's see the what is the approach. So let us consider that we have these particular nodes which are like one length, and then two length, and then three, and then four, and then five. So let us consider slow and fast pointer. Why are we considering slow and fast pointer? To get to the middle of the linked list, we need to find node which is like middle. That means it should be half of the length of the linked list. The the question gives will be like this. We are given a link head of the linked list, and we need to find n by third element which is present in the linked list. For this particular case as well, we can travel the total length, and then we'll come to n by 3. But one more approach is we can take slow, and then again we can take fast. And then if we want to find middle of the linked list, we'll traverse the slow with slow to slow next. But for fast, we are going to traverse fast to fast next, and then next. And then let's say we are given that we need to find n by 3. Then we are going to traverse fast to fast next, and then next, and then next. But the conditions which we'll be checking are different. Like fast next should not be null, fast will not be null, and fast next should not be null. So that is the case. So for different cases, we'll consider fast as like we should take twice or thrice depending upon the question. So for this particular case, the middle element for this element is going to be the current element itself. So for this particular case, the element is going to be this. And then for this particular case, as it is 2, so we are going to say 2 plus 1 by 2, which is like 1, and then we are going to say plus 1. So for this element, we are going to say this is the middle element, and then for this particular case, we are going to say this is the middle element, and then for this is a middle element, and then for this is a middle element. So let us do the traversal for slow and fast pointer. So initially we'll have slow and fast pointer here for this particular case, and then we'll check whether the fast and then fast next is null. If the fast and then fast next is null, we cannot traverse fast to fast next and then next. So we'll say this is the node which is middle element for this particular linked list, and it will be stored in slow, not in the fast. Fast is going to traverse the linked list faster, and then it will complete the linked list. By the time it completes the linked list, the slow will be at the middle of the linked list. Why? Because the fast is moving twice the speed as the slow, so it will reach the middle and then fast will reach end. And then let's say suppose we want to find n by 3, then that means this fast is going to traverse 3 times the speed of the slow. So then we'll get to the node where we'll have n by 3 speed, like it will be n by 3. So we'll be calculating like that. So for again consider for this particular case where we'll have slow and fast pointer. For this particular case, fast and then fast next is not null, so we'll move the slow to here, and then fast will be moved fast next and then next. So fast becomes null. Then we can return that this particular slow is the middle element. And then let us consider for this particular case where we have slow and then fast pointer. Now the fast pointer and then fast next is not null, so we'll move slow to slow next, and then fast to fast next. It is traveling twice the fast as slow, so it will be moved to 2 nodes, and then slow will be moved to 1 node. And then again we'll check whether fast and then fast next is null. Yes, it is null, so we are going to return this particular slow. So this is the middle element. And then let us consider for this particular case where we have slow and then fast. We'll check fast and fast next is not null, so and then we'll move slow to here and then fast to here, and then again we'll check fast and fast next. This will be moved to here, and then fast will be moved to here. So we'll return this particular middle element, and then again we'll take slow and then fast here, and then we'll move slow here, and then fast will be moved here, and then again slow will be moved here, and then fast will be moved here, and then we'll check fast and then fast next is null. Yes, it is null, so we are going to return this particular slow. So for this particular case, we are going to traverse the linked list only once, and then the space will not be taken, so it will be big of 1 time space complexity. Yeah, let's go through the code once, like how we are doing the slow and fast pointer. So let us take slow and then fast pointer as a head and then head, and then we'll check whether the fast is null or fast next is null, so that we'll get to know whether fast can traverse next time. That means if this becomes null, then null of next is not valid. So we are going to check fast and then fast next is whether this is right or not. And then for this we are going to traverse slow to slow next, and then fast to fast next. And then at last we are going to say slow is the middle element, so we'll return this particular slow. Yeah, that's all for this video. And then if we come to the space and time, the space is going to be big of 1, and then time is going to be big of n with 1 traversal. Yeah, that's all for this video. Thanks for watching the video. Have a nice day. Bye.